Welcome to School Page Video Teacher. Tenth CBSE Physics Chapter The Human Eye and the Colorful World. After watching this video, you will be able to understand the reason for twinkling of stars and understand the concept of advanced sunrise and delayed sunset. So let us study atmospheric refraction. Some of the optical phenomena in nature which occurs due to atmospheric refraction are twinkling of stars, advance sunrise and delayed sunset. Let us consider fire to understand a simple day-to-day example to understand atmospheric refraction. Today, try to visit a roadside vendor who sells masala puri or pav bhaji. You may notice the smoke is coming out from his gas stove. You may stand here and try to look at objects or people behind the smoke. You may observe that people or objects are actually moving. This is because of the change in the refractive index. Here the two different refractive index are hot air and cold air. Hot air has less refractive index, whereas cold air has more refractive index. Since there is a change in the medium, the hot air and the cold air, the refractive index changes for these medium. So this is an example of atmospheric refraction on small scale. So let's move on and understand atmospheric refraction on large scale for twinkling of stars and to understand advanced sunrise and delayed sunset. This is the beautiful view of the twinkling of stars in the night sky. Twinkling of star is due to atmospheric refraction. So let's understand in detail why do stars twinkle. So let's understand twinkling of stars. Let us consider this is the earth and these are the different layers in the atmosphere. So there are many layers in the atmosphere. We know that a star is several miles away from us. When light from the star reaches the earth, it undergoes refraction due to the varying optical densities of air at various altitudes. So when the ray of light passes through all these layers, refraction of light takes place. So this is a ray of light. If we draw a normal here, ray of light bends towards its normal. Again here it bends towards normal. So by the time it has reached the earth, you can see the shift in the position. When the atmosphere refracts more starlight, the star appears to be bright, and when the atmosphere refracts less starlight, then the star appears to be dim. So in this way, the starlight reaching our eye increases and decreases continuously due to atmospheric refraction. So the person will actually see the star somewhere here because our eye will see the star at that position from where light enters it in the straight line direction. This picture shows the apparent star position due to atmospheric refraction. So this is the direction where refractive index is increasing. So this is the actual position of the star. The bending of the starlight is due to the atmospheric refraction. But this boy can actually see the star at this position. So this is the apparent star position. Here you need to understand that the atmosphere is continuously changing, due to which the optical densities of the air at different levels in the atmosphere keeps on changing, due to which you can see twinkling of stars. So we have understood why do stars twinkle. But let's also understand why planets do not twinkle. Since stars are considered to be point source of light, because they are very far, the continuously changing atmosphere is able to cause variations in the light coming from a point-sized star, because of which the star appears to be twinkling, whereas planets appear to be quite big in size. So a planet can be considered to be a collection of a very large number of point sources of light, because of which the brightness of the planet always appears the same, and hence it does not appear to twinkle. So we have understood that planets do not twinkle because of the continuously changing atmosphere, which is unable to cause variations in the light coming from a big sized planet. So now let's understand the concept of advanced sunrise and delayed sunset. Did you know that we can see the sun about 2 minutes before the actual sunrise and 2 minutes after the actual sunset because of atmospheric refraction? So you should understand here that when the sun is above the horizon, we may say that the sunrise has taken place, and when the sun is below the horizon, the sun is set. Can you observe here? The sunrise has still not taken place, but still we can see the sun. This is because of atmospheric refraction. This bending of light is due to atmospheric refraction. So what happens here is, when the sun is slightly below the horizon, then the sunlight coming from less dense air to more dense air is refracted downwards as it passes through the atmosphere. So because of atmospheric refraction, the sun appears to be raised above the horizon when actually it is slightly below the horizon. So it is also due to atmospheric refraction that we can still see the sun for about 2 minutes even after the sun has set below horizon. So the time for sunrise and sunset is lengthened by 2 plus 2, which is equal to 4 minutes. So because of atmospheric refraction, the day is lengthened by 4 minutes. If the earth had no atmosphere, the day would have been shorter by 4 minutes. After watching this video, now you should have understood why do stars twinkle and understood the concept of advanced sunrise and delayed sunset. Thank you for watching. For more videos, visit our website videoteacher.schoolpage.me.